Hi, welcome to part 6 of the capsule and video series about impulse and momentum. We defined an isolated system and learned about the conservation of a linear momentum in the last video. The majority of the questions in this chapter involve object collisions. Collisions can be elastic or inelastic. We will learn about the elastic collision in this video and the inelastic collision in the following. An elastic collision is a collision where total momentum and total kinetic energy are both conserved. The preceding videos taught us that the system's total initial and total final linear momentums are equal according to the law of conservation of linear momentum. We can also adapt this equation to include kinetic energies for elastic collisions. The total kinetic energy of the system, both at the beginning and at the end, is the same. Although we can't actually say a perfect elastic collision since there is always some kinetic energy loss. The collision of pool balls can be regarded as such because the energy loss in this instance is negligible enough to be ignored. Ball P of mass 0.2 kgs collides head-on with another ball Q of mass 0.3 kilograms, as shown in the diagram below. Ignore the effects of friction and the rotational effects of the balls. Part A. Calculate the velocity of the ball Q after the collision. Two diagrams can be seen on the screen, one showing the balls soon before the collision and the other showing the conditions just after it. We can treat this system as an isolated system since we can ignore friction and other influences on these balls. In this case, we can start the answer by typing the equation stating that the total linear momentums before and after the collision are equal. Let's consider east as a positive direction. There are two objects that are moving independently both before and after the collision. Thus, the initial equation can be modified to say that the sums of the initial momentums of the balls P and Q equal the sums of their final momentums. The ball P's initial mass is 0.2 kgs and its initial velocity is 15 meters per second. The ball Q has a mass of 0.3 kilograms and a velocity of 5 meters per second west. The mass of P is still 0.2 kilograms after the collision, but it is now heading west at a velocity of 9 meters per second. So the velocity of P after the collision is minus 9. Q has a mass of 0.3 kgs and we must determine its velocity following the collision. 3 minus 1.5 is equal to minus 1.8 plus 0.3 times velocity of Q. As a result, velocity of the ball Q after the collision is 11 meters per second. The ball is traveling east because the result is a positive number. In the second part of this question, we have to find out if this collision is elastic or no, and then we have to give explanation to our answer. We already mentioned that the total kinetic energy is conserved in an elastic collision. Therefore, we must compute the total kinetic energy before and after the impact. Then, compare the results to determine if the collision is elastic or not. The collision is elastic if the solutions match, else it is not. Kinetic energy, as we all know, is 1 over 2 times the product of mass and the square of the speed. Kinetic energy of the ball P before the collision is 1 over 2 times its mass 0.2 kgs multiplied by square of its velocity 15. Kinetic energy of the ball Q is 1 over 2 times 0.3 times square of minus 5. The total kinetic energy of objects before the collision is 26.25 joules. Kinetic energy of P after the collision is 1 over 2 times 0.2 times square of minus 9. And the kinetic energy of Q is 1 over 2 times 0.3 times square of 11. These two add out to 26.25 joules as well. We can see that the total amount of kinetic energies before and after the collision are equal. The collision is hence elastic. We have studied elastic collisions in this video and worked through an example that relates to the subject. The same will be done for an inelastic collision in the following video. Thanks for watching. Don't forget to subscribe and turn on notifications in order to be updated about the new videos.